so exponential functions, we're going to graph them. We're going to do transformation. So that's like up, down, left, right, stretch, shrink, and reflect. We've done this very recently with radical functions, so it shouldn't be too far off in your mind. Should be pretty close. We're going to start with our a value. Okay, what do a values usually make happen? Stretch or shrink and or reflect. Okay, so the factor a stretches, shrinks, and or reflects the parent function. Bless you. Remember, our parent functions start like this and go up like a skateboard ramp or something. Right, that's just kind of what our graph looks like. We are going to start by graphing a shrink. It is a shrink because our a value, the absolute value of it, is going to be between 0 and 1. So this is going to be a shrink. Our a value exactly is going to be 1/2. All right, we are going to start by making a table. So we have two different equations here. We're going to graph this first. So let's go for our x values, -2, -1, 0, 1, 2, and 3. If we figure out one of these values, we can figure out the rest pretty easily. So which one do you want to try to figure out?
0.
0. That sounds good. Okay, if I plug 0 in, I'm going to work it out to the side here. That'd be 1/2 times 2 to the 0. Well, what's 2 to the 0? 1. So 1/2 times 1 is 1/2. All right, what is our growth or decay factor? Anybody remember where that is? It's the b. So what's our b? 2. So from here down, we're going to double this. So what's double of 1/2? 1. Double of that. Double of that. 4. Now going the other way, instead of doubling it, what are we going to do? Divide. So what's half of a half? A quarter. What's half of a quarter? An eighth. That's not that bad, right? Another way to do this is put this in y equals and go look at your table. Okay, that's another way to do it. So let's go ahead and graph that one. I think we can put, yeah, you can just put your axes like in the middle, like a normal graph. That was like the straightest line I've ever done. That's awesome. The other one's not very good though. Okay, so -2, 1/8. It's just barely off the line. The fourth is barely higher than that. Half is our intercept. 1, 1, 2, 2, 3, 4. We're going to graph two graphs on the same graph. That was a lot of saying graph. So I labeled that one so we know which is which. All right, let's look at the other equation. What is the only difference between these two equations? The negative, and the negative's in front of everything. So just change all these values to negatives. So -1/8, -1/4, -1/2, -1, -2, -4. We're just reflecting across the axis. For both of these graphs, what line are they approaching but never touching? The x-axis. What is the equation for that? Y equals 0. And what do we call that? The line that approaches but never touches? Anybody remember? It had a funny name. Asymptote. It's a horizontal asymptote, so I say HA. An asymptote. 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 I don't know. So they're both getting really, really close to 0, but never touching it. Any questions there? So this was a shrink. It got a little flatter than usual. All right, now the weird part about exponential functions, of course, has to go with h. Remember, h is always weird. So the deal with h is that a horizontal shift also, like, it looks the same as a vertical stretch or shrink. And that is because the shape of the graph, because it's just that weird ramp thing. So just know that those look alike. H is always weird. Now a vertical shift, again, as per usual, comes from K. K is the number hanging at the end. It's normal. We're just going to push the whole thing up or down, but it gives you an extra piece of information. Your K is your horizontal asymptote. All right, so horizontal asymptote is going to be y equals k. On the example above, we didn't have a k. There wasn't anything hanging out the end. So k equaled 0, horizontal asymptote equals 0. If there's a 7 hanging out the end, what will your horizontal asymptote be? 7. Okay, so you know your graph is shifted up 7. All right, h and k are the same as we've been dealing with all semester. H is stuck right there with x. Since x is an exponent, h is also in the exponent. Remember, h is backwards. When it's positive, it goes left. When it's negative, it goes right. K is always tacked on to the end. It's just the number at the end of the equation. Okay, h is horizontal, k is vertical, and your horizontal asymptote. This is just like a summary thing down here to kind of get all our thoughts in one place. Any questions so far? Okay, our next step is to actually graph one of these that's moved up, down, left, right. So we are going to start by graphing this equation here, and then we'll show how its movement with this one. So we need to start here. I'm going to make some axes. See if I can do straight line again. It wasn't the worst. That one wasn't the best. So I'm going to do my same points again. -2, -1, 0, 1, 2, 3. We'll see where that puts us. Which one you want to try to figure out? 0 sounds good. Okay, so if you plugged in 0, that would be 8 times 1/2 to the 0. So just 8. Okay. And what is our growth or decay factor here? It's 1/2. It's whatever x is attached to. So as we move down our list, we need to break it in half. So the next one would be 4, 2, 1. And then going up the list, next would be 32. Okay, I don't think we're going to be able to fit 32 or 16 on our graph. We can almost fit 0, 8, so I'm going to start there. 0, 8, 1, 4, 2, 2, 3, 1, and then you can keep going. So 4 would be a half, 5 would be a fourth, and that's good enough. So what's that one approaching but never touching? The x-axis again. So our horizontal asymptote is y equals 0. And that one was y equals 8 times 1/2 x. So the next one, I don't even want to make a table for, because we can figure this out from what we just graphed. What is the 2 going to make happen?
Up 2.
The 2 is with the x, so what's usually with x? H or k? H. Remember, H is horizontal. So is it going left or right? Left. It's going to go left 2 from right here. So left 2, and then what from the 3? Up 3. So all the points, I'm going to start here. You're going to move it left 2, up 3. And there's your new point. Left 2, up 3. Left 2, up 3. Left 2.
One of the points stay the same.
Yep. What should our horizontal asymptote be?
Where'd you get those 3 other dots?
I just added them in from down here, so I knew that's what would be next. So this one, our horizontal asymptote is y equals 3, because that was our k value. Because the whole graph just shifted up 3, so the asymptote goes with it. Any questions there? Remember, your graphing calculator is far too nice to you, and will give you tables to help you out. Okay, that finishes the graphing part of your homework and our notes. The next part, we have another special number that gets its own name, its own letter, and that is the number e. So we have pi, we have I, which is the square root of -1, and now we have e. Where we get e from is this crazy equation here. It makes a graph that looks like this. And that graph has a asymptote at y equals e. E is this decimal that goes on and on and on. That's approximately what e's value is. So this is e. You do not have to memorize that, luckily, because your calculator has a button for e. Can you find it? It actually says e to the x. So somewhere on your calculator it says e to the x. Where is it? is right there. It's second what? So you're going to press
From the on button.
second ln. It's 2 up from the on button. Very good. All right, so that is where you get E. All right, E is the reason why it's special is that it's really useful for describing continuous growth or decay. So that's like interest on loans or interest on money you have in the bank. Okay, so that's why it's so awesome that it gets its own letter. So you are going to find E, and yours doesn't have this, doesn't have this, doesn't have this. I forgot to update my PDF. Okay, so we're supposed to figure out what E squared is to 4 decimal places. So you need to press second ln and then put in a 2. So it should say E squared, and then what does that equal? 7.389. What's the like decimal? Like if you were just to read the decimal off, 3905605 something. So we're supposed to round to 4 decimal places, so it'll be 7.389, as Levi said, 1. So there's your answer. We round up because there was a 5. All right, so the point of those problems is mostly for you to get used to where that button is on your calculator. So practice using it.
I feel we'll be using it in the future.
Do what? Okay. So our next problem is a real-world connection, as it says. We're going to figure out how much money you have in the bank because it's been compounding interest. It says, suppose you invest $1,050 at an annual interest rate of 5.5% compounded continuously. Okay, so what that means is you put $1,050 in the bank. Every year, the bank will give you 5.5% of that money for free, for basically letting them keep your money for it. Okay, so 5.5% of 1050 you get for free every year. But when it says compounded, what does that mean?
It carries on to next year.
It carries on to the next year. So after the first year, you're going to have some money added to the 1050, right? So the next year, the 5.5% comes off of that total. And then the next year, it's off of the new total, and new total, and new total. So compounded means like off the new total. Okay, so how much money to the nearest dollar will you have in the account after 5 years? Well, luckily, there is a beautiful little formula over here to the side that you are going to use for this. All right, so you're going to use that formula on your homework. It looks like A equals PERT. A is the amount in the account. So that is what we are looking for. A is our question mark. P is principal. That does not mean like Mr. Smiley. Principal means the original total or original amount. So P is 1050. E is E, the button on the calculator. In our exponent, we have R as the rate of interest. And this formula is for annual interest, which is what we're using. So what was our interest rate? 5.5%. We can't put percent in the calculator like that, so how are we going to have to put it in? 0.055. Remember, you just move your decimal place to the left 2 spots. Okay, and then T is time in years. How many years are we wondering about? 5. So in your calculator, you're going to figure out what A is by plugging in 1050 e to the 0.055 times 5. And that should give you your amount. 0.4, and it asked us for nearest dollar. So would we round up or leave it how it is? You leave it how it is because it was a 4, so we don't round up. So after 5 years, you would have gained like $332. It's not bad for money just sitting there. It's better than it sitting underneath your mattress and not gaining anything.
I think Mr. Griffin made us do a project like this. This
Really?
would come handy.
This would have come in
Yeah,
handy.
it would have come in handy.
You have to figure it out step by step.
I did it one by one, like, and if the calculator reset itself, I have to look back and around.
Oh no.
Yeah, and that was horrible.
I actually did that.
And then people were cheating on using PowerPoint, or not PowerPoint, not Excel.
Oh.
They look around to like
He
the small
doesn't do it
stuff.
anymore.
Oh. Well, here you go. All right. Any questions over today?
Excel, just drag down.
Yeah, drag.